command chaining, let's just note, command chaining is not dependent upon the exit status of the most recently executed command. This may suit some situations where you need command B to run regardless of the output or status of command A, and C to run regardless, and so on. But for other scenarios, that may not be ideal. If this is ideal, use a semicolon. Let's just note, runs both commands independently. They happen in sequence, so of course the remove RF happens first, but if it fails or succeeds, or whether it fails or succeeds, ls-l will continue to run. So that's how command chaining works. But there's another concept that's of importance when navigating the shell. So in addition to piping and command chaining, and that is the ability to make commands dependent. So command dependency using logical ANDing and ORing. So AND or OR. One example of this is, for example, remove RF temp star, which is going to fail, or LSL. Let's see what happens when we run this combination. So the shell is going to fail to remove temp. Let's drop our privileges because it's always a good idea to perform removals as a non-privileged user. And we are in our home directory, and if we lsltr, we'll see that temp doesn't exist. So this is logical ORing. Let's echo. Now, the removal failed. So because the removal failed, we didn't get the ls. So in this case, removal temp didn't work, ls-l didn't work. Now, what about logical ANDing? Using double ampersand, this will build in a dependency. So remove RF temp star and ls-l. So to use logical ANDing, we use double ampersand. And to use logical ORing, we use double pipes. But in this method, a dependency is built in so that one only executes if the other is successful. So let's note, remove RF temp star and ls-l. Or more simply, let's go with pwd and ls. Well, pwd executed, ls executed. Let's break pwd and execute a command that doesn't exist. pwds doesn't exist. Now, the most recent example seemed a bit peculiar, and that's because remove worked. It was not able to remove, or the shell was able to find remove. Remove couldn't find the temp directory to remove, but it did work. So it generated the output that we saw. Now in this case, when we indicated that pwds is to be executed, the shell couldn't find it, generating an exit status, causing ls to fail. Now for example, if we do pwds followed by an echo of the exit status, it's non-zero. That's why it fails. Because pwds generates non-zero, ls doesn't run. Now what if we did pwds or ls? Well, pwds failed, so run ls. In other words, if the left fails, run the right. And that's another form of dependency. So in this case, run ls-l if rm rf temp star fails. And in this case, run ls-l if and only if remove RF temp star succeeds. So those are your dependencies. So you have a sort of command chaining where you use semicolons where everything will execute regardless. And then you have these dependencies where it's logical ORing, logical ANDing. The logical ORing says do the right if the left fails. The logical ANDing says do the right only if the left succeeds. Now you're not relegated to just for example, 2 commands. You can string together a number of commands, 3, 4, 5, or more. It's entirely up to you. So you could have a long string, for example, pwd, and if pwd succeeds, ls, that's 2 commands, and if ls succeeds, ps, so now you get all 3 running, and they have to run in succession of exit status, the statuses that are 0. So if pwds breaks, ls won't run. And if ls doesn't run, ps won't run. So as you can see, because pwds fails, the whole chain fails. Now if pwd succeeds and let's say ls fails, let's call ls lss. Well, lss fails, so ps doesn't run. So the dependency is based on the most previously executed command. If it's successful, the item to the right of the double ampersand will run, or at least attempt to run. Whereas in the case of logical ORing, let's change these ampersands out to logical ORing. And in the case of pwd, ls, ps, well, pwd executed, so no need to execute ls, no need to execute ps. Now let's break pwd. Pwd has failed, so ls executed, no need to run ps. Let's break ls. This will cause ps to execute because all of the left has fallen apart, in this level that is, allowing ps, the rightmost object, to execute. So command chaining, logical ANDing, logical ORing are mechanisms that are important in writing shell scripts, and they help you to navigate accordingly. Now we've mentioned that a history is maintained of shell commands. That's command history. It's maintained by the bash shell. If you type the history command, you'll see that history. If you do a which history and it's maintained on a per user per shell basis, this is a built-in command, meaning it's built in. So built-in command, that means it's within the bash shell interpreter. As a consequence, there is no file on the disk that correlates to this particular command, but it's available at your disposal, courtesy of the shell. When you execute history, you see all the commands that we've been running thus far that pertain to this particular shell. Your history items are maintained in a hidden file in your home directory, .bash_history. This is the file. Let's look at it. Notice I'm tacking on the ls option to the right of the file. Some commands like ls permit this, and on Linux, not necessarily other Unices. So the command file is 39 bytes. And if we cat the contents of bash_history, you'll see what it contains. So this appears to be written from the main window, perhaps from the first window that we executed. Indeed, tty. So that comes from, and if we search through this history, it should be from that window, or at least it appears to be. So history contains the items that are in your history per shell, and it differs per shell. If you navigate to this sudo terminal and execute history, notice that the command history differs. It appears to have come from this shell, that is, that's maintained that file. Let's look at the contents again, cd, vnc password, indeed. So this particular shell is in tune. The most recent shell, recently invoked shell, is tuned into the history file. And the other shells that were open have lost access to the main history file. So it's maintained in that fashion, with the most recent invocation considered to be the most dominant or most applicable. So the history file is maintained there. Now there are a number of bash configuration files. If we ls-a for hidden files, you'll see these bash or hidden bash_ files. For example, bash_logout, what to do when you log out of the system. Bash_profile contains variables in bash_ or in bash rc. Let's lsla.bash star, and you can see that bash_logout is a small file, and it just has an execution of bash_logout, but there's nothing in it. And let's cat the contents of bash profile to see what's set when we log in. So when we log in, it looks for bash RC in the user's home directory and it sources it. That's what this leading dot means, meaning it includes the contents of that file at this point of the configuration process, and it sets a path. Whatever path has been previously defined, plus it tacks on home bin for binaries that are to be executed beneath the user's home directory, and then it re-exports the path. So the system sets up a path for you, but then this bash underscore profile file that's hidden adds home underscore bin or home/bin. That's where it comes from. So if you wanted to change that, you could do it there. And it updates the environmental variable for path. Let's take a look using the less pager at bash underscore bash RC, that is. And this file simply sources the global bash RC file to ensure that we get variables from there. So if you look at it from the perspective of bash profile, it sources the user's bash RC, which sources the global bash RC to inherit all of those variables. And so far as those variables, you can type env to see the variables. And if you do env grep any of the variable names that are of interest, such as home, you'll see the variable. So here's our home variable, or log name, for example, or mail, the path to it, or our path variable. So env grep path using a pipe shows us the path. Or if you echo any of the variables defined, such as log name, the contents of the variable will be displayed to stand it out. For example, old PWD. Let's just note that as well, since it comes to mind. Note, bash maintains a number of variables per shell. And one of them that you may want to keep in mind is old PWD, updated as you navigate the directory tree, as well as log name, shell, which reflects the current shell that you're using, etc. A number of variables. So environment, let's just echo the shell to see what it reads. It's bin bash. There are also variables for the version of bash that you're running, your terminal, the settings, whether or not SSH is running, VNC, you name it, the user who's currently logged in, etc. So a number of variables are maintained. Another way you may see your variables is to run the set command, and it shows a number of variables. And you may also use export and set to set variables. So export is another command. Export exports vars. So supposing you wanted to update your path variable, let's echo path. So path contains the following, including home Linux CBT bin. What if we wanted to include, let's say, /temp in the path? Well, we could then export path, setting it equal to the current path, colon as a delimiter, the same format you see here, /temp. Echo the exit status, and now when we re-echo path, which is in our history, we see that /temp has been tacked on, which of course begs the question, how does the export of one shell, one pseudo terminal in this case, pseudo terminal 1, impact, let's say, pseudo terminal 0 or pseudo terminal 4? Well, echo the path from those shells and you'll see that temp is not included. In other words, the export of a variable is specific to that particular shell. When the shell starts, it reads its startup instructions from the appropriate bash files, and they're set, and they're not changed until you either source a new file, or source a new shell, that is, or reincorporate the contents by closing the shell, relaunching the shell, or sourcing the file where you've stored the variables, thus reincorporating the contents. So there is no impact to the other shells that are currently running. That's what you need to keep in mind. So export, as an example, export path equal to the current path colon /temp appends /temp to current shell's path. Let's just save the changes to our document. And again, there's still a number of other commands that are of interest. More is another one, which is a pager like less that I use less often. So more, similar to less, something to keep in mind, and a number of other commands that we'll be looking at. We've covered some of the key ones that are of interest, that are important. But the key, I think, for this section surrounds command dependency, command history, command chaining, input, output, append redirection, and some of the more important ones like touch, echo, so on and so forth. Let's just throw a few more in there. CP copies data. MV moves data. So if you need to copy files, and let's just show you a quick example, from one directory to another. This is just standard Linux stuff. So let's take test.txt. Supposing we wanted to put this in the temp directory. Well, we'll make directory temp, and if that's successful, using logical ANDing, we'll then copy. Let's turn on verbose option. It's one of the CP options which you can expose using --help. We'll copy test.txt into the temp directory. And then if that's the case, if that's successful, let's lsl temp. Notice the copy output shows and the lsl shows. So this worked successfully with an echo of the exit status to reflect that these steps were carried out successfully. Let's copy this and paste into our notes as a simple usage of the copy command. And then similarly, if we move, let's create a chain here. So let's move test.txt into the temp directory. And if that's successful, lsl the current directory. And if that's successful, lsl the temp directory. And if that's successful, echo the exit status. So this is just a simple chain of a number of commands that we'd probably run in sequence on separate lines. Let's see how this works out. And notice the echo of the exit status, 0. Sometimes for your scripts, it may be worthy to echo some sort of prefix before the variable. So for example, note in scripts, prefix exit status with meaningful text, i.e. echo, let's say the word exit status, and then include the variable, for example, so that when you see it on the screen you know what it means, because oftentimes with considerable output it isn't clear what you're looking at. So this shows exit status 0, and this can be included in a whole command stream. So for example, let's move test2.txt and go through the whole process. So we'll paste our echo of the exit status, and instead of test.txt we'll move test2.txt. By the way, I'm able to move or navigate within the shell from the end of the command line to the beginning using Control-E to go to the end and Control-A to go to the beginning. Control-F takes you forward, Control-B takes you backwards. That's a neat way to navigate the shell. Let's just note, bash shell allows simple navigation using, and of course including but not limited to, Control-A takes you to the beginning of the line, no matter how long the line is. Control-E takes you to the end of the line. Of course, this means the command line. Control-B takes you back one character. And Control-F forward one character. And there are a number of other options. These aren't the only options that are available. These are just some that I use more frequently. So let's try to move test2.txt into temp. LSL the current directory, and then LSL temp, and then echo the exit status. There you see exit status 0 is more meaningful, simple script, and now the contents of temp include both of those files. They've been moved successfully using logical ending form of command chaining. So next we'll continue looking at more useful basic Linux commands.